Welcome to this explainer. Have you ever looked at a beautifully landscaped backyard pond as the snow starts to fall and wondered, how on earth do the fish survive under all that ice? Today, we're taking that practical pet care question and turning it into a really fascinating deep dive into biology, anatomy, and physics. So let's just get right into it. Can your delicate, fancy goldfish, the ones with the beautiful round bodies and flowing fins, actually survive a freezing winter outside? Well, it turns out the answer unlocks this gripping scientific mystery right in our own backyards. As we'll see, it's not just a simple yes or no. We're looking at a story of centuries of genetic modification crashing headfirst into the extreme forces of nature. To solve this mystery, we're going to follow a pretty clear path. First, the winter question. Then we'll look at streamlined versus fancy anatomy. After that, the biology of cold water, followed by the frozen pond, and we'll wrap it all up with the final verdict. Let's kick things off with part 1, the winter question, and set the stakes for survival. Let's look at what these fish are actually facing when the temperature drops. Our starting point is actually a huge misconception. Goldfish are often sold for just a few bucks right next to absolute beginner fish like neon tetras, but fancy goldfish are absolutely not for beginners. They're highly specialized, delicate creatures. They need pristine water, heavy filtration, and really meticulous care. If you treat them like rugged wild carp when winter rolls around, well, it's basically a recipe for disaster. That brings us to part 2, streamlined versus fancy anatomy and the biological divide. To really understand winter survival, we have to look at the shape of the fish itself. It's wild how centuries of selective breeding have completely altered them. Think of the long, torpedo-shaped, streamlined goldfish, like your commons and comets, as the rugged wolves of the aquatic world. They still have that wild-type body. On the flip side, the globular, heavily modified fancy goldfish, like orondas and ranchus, they're basically the delicate pugs of the water. They've been bred purely for aesthetic traits that are completely opposed to surviving extreme natural environments. And this leads right into one of the most absolutely crucial organs for making it through the cold, the swim bladder. In a streamlined fish, this organ is long and horizontal. But because fancy goldfish have been bred to have this compressed egg-like body, their swim bladder is often deformed, displaced, or just totally crowded by other organs. That makes them incredibly vulnerable to losing their buoyancy control the second the water gets cold. The main takeaway here is that this cramped internal anatomy severely handicaps them. When the temperature drops, their squished gastrointestinal tract really struggles to process food. That deformed swim bladder we just talked about, it can cause them to literally float upside down or sink like a rock. Plus, their delicate head growths called wens and those protruding eye sacs are super easily damaged by ice. Combine all that with clumsy swimming, and they just can't quickly retreat to warmer water. All right, part 3, biology of cold water and the science of ectothermic metabolism. Let's see what actually happens to their internal chemistry. So, goldfish don't just hibernate in a cozy cave like a bear. They're what we call urothermal ectotherms. That's just a fancy way of saying their internal body temperature and metabolism are entirely controlled by the water around them. As the water drops down toward 50 degrees Fahrenheit, they enter a state called torpor. Their heart rate just plummets, they hover down near the bottom, and their energy use drops to near stasis. Now, pay close attention to this feeding rule because it's literally a matter of life and death. When the water dips below 50 degrees, a goldfish's digestive enzymes basically turn off. If you feed a fancy goldfish at this temperature, the food doesn't get digested. It just sits inside their cramped gut and rots. This causes massive gas buildup and fatal bacterial infections, which completely destroys whatever swim bladder control they had left. So below 50 degrees, you absolutely do not feed them. Also, surviving months of torpor takes fuel. Breeders follow something called the 4-inch rule. Basically, juvenile goldfish under 4 inches just don't have the liver glycogen and fat reserves stored up to survive months without eating. So winter is especially deadly for the little guys. If a fancy goldfish doesn't have the mass to sustain itself, the cold will claim it before spring even arrives. Moving on to part 4, the frozen pond and the physics of a winter water garden. Because the cold isn't the only thing trying to kill them. This is where the physics gets really cool. 39.2 degrees Fahrenheit or 4 degrees Celsius is a magic number. Because of the anomalous density of water, it is actually at its absolute densest at exactly this temperature. That means this slightly warmer water sinks straight to the very bottom of the pond, creating this stable thermal sanctuary for the fish. while the freezing, 0-degree water floats to the top and turns into ice. If your pond is deep enough, usually at least 3 feet, that sanctuary stays intact. But there's a catch. If the surface freezes completely solid, you run into the primary cause of winter fish mortality, suffocation and toxicosis. All the dead leaves and organic waste at the bottom keep decaying over the winter. This process releases lethal gases, especially hydrogen sulfide, which smells just like rotten eggs. If there's no hole in the ice for those gases to vent out, they accumulate in that bottom sanctuary and silently suffocate your fish. No way around it. So, to vent those gases, you absolutely have to keep a breathing hole open in the ice. You can use a thermostatically controlled floating de-icer or a low-wattage aerator. But here is a critical tip if you use an aerator. Keep the air stone at mid-depth. If you drop the bubbler all the way down to the bottom, you're going to accidentally mix the freezing surface water into that 39.2 degrees safe zone, and you will literally chill your fish to death. All right, part 5, the final verdict. Can they stay outside? Let's bring all this biology, anatomy, and physics together. The final answer really comes down to the genetics of your specific fish. Those streamlined wolves, the comets and commons, yes, they can absolutely survive a deep pond winter. But the delicate, pug-like fancy goldfish, no way. Orandas, ranchus, and especially extreme breeds like the bubble-eye face a massive, often fatal risk of buoyancy failure, digestive impaction, and freezing. For them, staying outdoors in winter is a definitive no. And get this, even if a fancy goldfish somehow survives the freeze, they face a terrifying, silent killer called the spring gap. As the ice melts and water warms up to around 45 to 55 degrees, opportunistic parasites and bacteria wake up and start multiplying rapidly. But the goldfish's immune system needs much warmer water to reactivate. So during this gap, the stressed, weakened fish is completely defenseless. So what's the solution? The safest, most scientifically sound method for fancy goldfish is the indoor transfer method. Before the deep freeze hits, move them into an unheated garage or basement in a large stock tank or tote. Throw in a gentle sponge filter and make sure to acclimate them slowly over several hours so you don't shock their system. By keeping the water in that cool 45 to 55 degree sweet spot, you give them a natural winter rest, completely removing the threats of toxic gas, freezing, and predators. We've unpacked a massive amount of biology and physics today, all from asking one simple question about a little fish. Honestly, next time you see a fancy goldfish swimming around at the pet store, I hope you remember the incredible environmental physics and delicate biology hiding under those beautiful scales. It really makes you wonder, if we've altered these pets so drastically just for aesthetics, what other common animals are quietly fighting a daily battle against their own modified genetics? Thanks so much for exploring this with me.